Our next stop is the quintuplet cluster, a massive 4-million-year-old cluster named for 5 supergiants dominating its center. It is also home to the Pistol Star, one of the brightest stars in the entire galaxy. The cluster has 5 mysterious supergiants whose secrets are shrouded by red dust clouds. In 2006, puzzled scientists tried to get a closer look at them. Using the Keck telescope in Hawaii, what they found was startling. 2 of the stars are surrounded by bizarre spirals, which means the supergiants are not alone.
In the quintuplet star cluster, there are several massive stars that are in fact in binary systems, and they're in the process of gently blowing away their outer envelopes. And those envelopes are colliding and forming this spiral pattern. It's very unusual to find several of these things in the same place. Such stars are very rare. If you look elsewhere in our galaxy, you'll find one every once in a while here and there, but not several of them in one concentrated location.
It's only a matter of time before these and any of 100 other supermassive stars light up the cluster with supernova explosions, blowing away their own planets and wiping out any civilizations on neighboring worlds with deadly radiation. Similar dangers lurk inside another cluster close to the galactic center. It's called the Arches Cluster, 25,000 light-years from Earth and just 100 light-years from the Milky Way's core.
The Arches Cluster was the first young massive cluster discovered in the galaxy. It is the densest young cluster in the galaxy.
Our own sun's neighborhood is practically empty compared to the Arches Cluster. In the 50 cubic light-years around the sun, the only neighbor is the Alpha Centauri system. If we were in the Arches Cluster, the stars are so tightly packed, this same space would contain more than 1 million stars, lighting up the sky of any planet both night and day.
If we lived on a planet surrounding a star in the Arches Cluster or a cluster that's similarly dense, we would see thousands of stars in the night sky. In fact, some of those stars would be so bright that they would individually be much brighter than the full moon. The night sky would be very bright. It would be comparable to the light level in an office during the day.
The Arches Cluster is a major landmark in our galaxy because it was used by scientists to figure out just how big a star can get. Our search for cosmic clusters has taken us to the Arches, one of the most important clusters in our galaxy. It's here that scientists discovered just how massive a star can get.
That seems like a simple question, but we didn't know up until a few years ago how massive a star could actually be.
The Arches had everything scientists needed to answer this question. First, in such a big cluster, there were surely many massive stars to study. Second, at roughly 2.5 million years old, the cluster was young enough that its massive stars wouldn't have exploded yet. So the biggest star in the cluster would probably be a good guide for how massive stars can get in the wider universe.
What we saw in the Arches is a collection of many, many low-mass stars, not so many, maybe hundreds of medium-sized stars, and then a dozen or so very massive stars with 130 times the mass of the sun in them. Beyond that, we saw nothing. It was like falling off a cliff. If stars more massive than about 130 solar masses can form and live, then they would have been there in the Arches. So apparently, nature has placed a limit on the maximum mass of a star. It's probably somewhere between 130 and 150 solar masses.
As we travel away from the very young Arches Cluster, we chart a course for a very different part of the galaxy. Out in the Milky Way's quiet suburbs are its senior citizens, the Globular Clusters.
A globular cluster sounds so wonderful. It's one of my favorite words, a glob, and that's exactly what it is. Often up to 1 million stars in a tight, large cluster. These things are really mysterious because they seem to be very old, some of the oldest stars in the galaxy. In fact, some of the stars are so old, they're practically as old as the universe itself.
Though they are visually stunning, it's the age of the globular clusters that makes them so exciting. Since they are nearly as old as the universe itself, they raise the question of the galaxy's age. Is the Milky Way as ancient as the universe itself?
We have good evidence that the universe is about 13.7 billion years old. Given that the oldest globular clusters are about 13 billion years old, this means that they formed within the first billion years after the Big Bang. This essentially marks the birth of our galaxy, and we think other galaxies as well, in many cases, were formed within the first billion years after the birth of the universe.
Scientists don't know how globular clusters form. It's one of today's enduring mysteries of astronomy. Because they are found in other galaxies too, it may have something to do with galaxy formation itself.
Because we see that individual stars and globular clusters are very old, in some cases being dated to 13 billion years old, we know that the globulars are that old, and we know that they were formed right at the time when the galaxy was forming. It's still unclear whether the system formed first and then the galaxy condensed out of the remaining molecular cloud, or if they condensed and collapsed and formed at the same time.
Finding globular clusters takes us outside the chaotic disk of the galaxy, where most of the stars reside, and to a place called the galactic halo.
The halo of our Milky Way galaxy is a vast, roughly spherically shaped distribution of stars that's around, it envelops the disk of our spiral galaxy. It's where the globular clusters live.
There are about 160 globular clusters now known, but it's believed there were once many more of them. Their presence in the halo, outside the influence of the galactic disk, may figure into the way they keep their spherical form. It may be that any globulars near the disk dissipated long ago. But there's at least one cluster out in the halo that's in danger of being ripped apart. A cluster that has lost 80% of the stars it had when it was first formed. We set our course for globular cluster M12 to get an up-close view of the devastation.
M12, instead of orbiting outside of our galaxy or going through the outer edges, actually passed close to the center of our galaxy. And when it did that, the gravitational interaction with all the other stars inside the Milky Way was strong enough to pull off some of the low-mass stars inside the cluster. So what's happening is that M12 is slowly losing its lowest mass stars with every successive passage through our galaxy. And eventually, there's not going to be anything left because it will have been completely devoured by the Milky Way.
For now, most globular clusters remain very crowded. 60,000 times as dense in stars as our own galactic neighborhood. But because the clusters are old, any massive bright stars they once had have long since burned out. The globular cluster sky would be crowded, but its glow would remain subtle.
If we were on a planet around a star in a globular cluster, we would see thousands of stars, but the average illumination at night would be comparable to the illumination you'd experience in a room with some candles lit up.
Orbiting out in the halo, globular clusters are to the galaxy something like moons are to a planet. Globular clusters on the outskirts of other galaxies show that this is something many galaxies have in common. Now, our route through space takes us far outside our own galaxy. 60 million light-years away to a massive elliptical galaxy called M87 that looks something like a globular cluster itself.